To manufacture a softball bat, it takes 2 steps. First step, I'm going to write this down. First step, cut a rough shape. Okay, I'm not writing that. I'll write rough shape, I guess. Rough shape. Second step, sand the bat to its final form. So sand. The cost to rough shape a bat is 45 cents. So if we're talking about cost, this is going to be 45 cents per bat. 45 cents per bat. Then it says, and the cost to sand the bat to final form is $1.05. The total fixed cost, so the fixed cost, base bills and stuff like that that don't depend on the number of bats we're talking about, is $16,500. How many softball bats must be sold at a price of $7 to break even? So the price for these bats is going to be $7 each. Per bat. Does somebody want to come up and do this? Do you kind of see what we're supposed to do? What is it we're looking for? Read the objective in the problem. That'll even help you beyond looking at the pattern. What are we trying to find? The number of what? The number of bats. The number of softball bats. So goal, find number of bats, softball bats, to break even. So same kind of strategy here, right? But if you look at exactly what it's telling you to find, what number, find number of bats, guess what your variable should be if you can do it, if you can define your variable display, which you can. Number of bats. A lot of times if you look at what it's asking you, that will also help you decide what X should be, what you should let it stand for. So for clarification, I'm going to write it. That way when I set up my formulas, I don't make any mistakes about how I use this X. Let X equal number of bats. Let's talk about the cost, people. Help me set it up. We have a fixed cost. Does X go beside that one? No. What about 45 cents per bat? Yeah, sure. It's depending on the number of bats, right? So 45 cents times X, and what else times X? Okay, 1.05. Let's write that. So cost. We had a fixed cost of this plus 45 cents per bat plus $1.05 per bat. And we said that selling price is equal to what? How can I calculate how much I'm selling it for, or how much I'm getting at the cash register? How much am I charging per bat? $7. So $7 per times X. And what do I want to do to break even? To know that one is not bigger than the other makes them equal. Okay. So with these word problems, this is actually a good warm-up for today. With the word problems that you're seeing, once you get to the algebra, you should already have that. You should have learned that already in the last 2 classes. And if you haven't, be asking me questions to get it. What shall I do here? Combine like terms. Sure, let's clean up each side first. What do I get here? Okay, 1.5 or 150, either one you want to write. Okay. Now that I want my x's on the same side, right? I'm going to move the 150. When I move it, the sign in front was a plus. What's it going to be now? A minus. And I keep throwing this number wherever. You put it where it makes you comfortable. I haven't decided yet where I like it. But the idea is it went to the other side of the equals and the sign in front changed. So this thing canceled when it moved. So now we have 16,500 equals, what do we get there on the right? Okay. We still want x alone, so what shall we do? Divide. To get off that 550 there, the 5.5, you do the opposite of what's attaching them, and they were attached by multiply. So you choose to divide. X is equal to what? 3,000 even? On the test, guys, I'm not happy with this. I need to know more. What does the 3,000 mean? Interpret it for me. Make sure you can go back and take your variable and put it into words, okay? That number that you solved for. Otherwise, it's kind of useless in a word problem. We want to find how many numbers are we finding? 3. We want to find 3, and they're going to be consecutive. That's important. Even or odd? Even. So we'll make sure to put that in the definition. Consecutive. Even. Does it say integers or numbers? Integers. I guess it doesn't actually make a difference in how you do the work, but okay. That's the first part. So I'm going to stop there. I'll put, blah, blah, blah. We'll look at the other part in a second. First, let's get this thing prepped, and then we'll use the next words to help us out with it. So, I'm going to say our first even integer. What do you guys want to use to represent that number that we don't know? X. Okay. Our second even integer. And obviously these are consecutive. I'm not putting that, but here, consecutive. What is it? What's the formula regarding the x? X plus what? X plus 2. Okay? So on these, you do the exact same thing. You just define it like this. And for the third even integer, also consecutive, it's x plus what? 4. Because again, we saw that pattern where every single one, you start with 1 and you add 2 every time as you walk, right? That's the most important, that's the hardest part of the problem. Right there. I mean, I know the next words sound hard, but this setup was the essential stuff. That's what I'm trying to say. This is what determines if you're going to be okay or not. And I guess I'll put the word let. I tend to call these let statements when I define all this stuff. Now that in words, I'm going to try to write down the simplest words I can the next phrase of this problem so that I can use my definitions up here to help me. Let's see. It says, such that 3 times the middle integer. Okay. 3 times middle integer. What about it? Of the first and third? Okay. Let's do literal translation. We have our definitions up here. Let's see, 3 times. Well, obviously 3 means 3. Times means multiply, right? But this might be catching your attention. Middle integer. Of these three I've written, which one's in the center? The x plus 2. Okay. So in place of that, I'm going to put in parentheses to represent the whole thing. I always use parentheses when I first write it. I'll put x plus 2. Everybody okay? Is. What does is translate to be? Okay. 4. Number 4. And more than, we know that the than technically throws it, so you can put it at the end or in front because it's plus. Where do you guys want to put it? You want to go ahead and throw it since it's got the than? So we're going to toss this thing to the end of its side, a 4, and we know there's a plus attaching it. Okay? So now let's look at this part. The sum, what's sum mean? We're going to plus. Here's the joint word. So the sum, the plus is going to go on and. What's the first? X. And the third? Oh yeah, and we still have the plus 4 right there on the end, right? So we got x plus 4. That all came from right there. That's where I got that stuff, right? Then we said, okay, we can't forget this plus 4 from right there. So we'll put that at the very end of this statement, plus 4. Everybody with me? Brittany, how you doing? Are you okay? And then I'm going to bring the other side, the easier side down. That was the easiest one to translate. Again, you could have stuck a plus 4 anywhere. But technically, some people like to use the properties of than and throw it to the end. With plus, it doesn't matter so much. With minus, it would have mattered. But you throw it to the end of the side. This green stuff here, we just substituted in for the first, the x. For the third, that was x plus 4, with a plus in the middle. And then we remembered, oh yeah, plus 4. That came from the start of it, so we'll put that there. Let me make the highlighting match, so you can see it maybe clearer. I don't know. That's where that came from the green chunk. And then we got that from the beginning of the problem. Hey, don't correct me. You guys okay? You like my colorful teaching? It's so pretty. Okay. Now you just solve it. You can, I'm going to rewrite this thing because it looks so crazy the way I wrote it. So we have 3 times x plus 2 equals x plus 4 plus 4. We simplify each side. So on the left, what should I do? So 3x plus what? Okay. Over here we don't distribute. We basically just drop those parentheses though. So that's the same as x plus 4 plus 4. So what do I really have on the right? Okay, sounds good. We still want to solve for x. That's always our first objective. Then we go back and see if there's more steps. So to get this x, let's move one to the other side. Which one do you guys want to move? Okay. So we're going to take 2x. When it moves, what happens? Okay, it's going to change the sign in front. So it was positive, now it's negative. That cancels this one. So now I have, let's see, my negative 2 and my 3 give me 1x plus 6 equals 8. Let's go back up here now. So we said that x is equal to 2. What does that mean about this one? Plug in the 2. What do we have? Okay. And then for the other one, you plug in 2, and what do you have? 6. You see what I did? I just plugged in the 2 for each x. Okay, there's our answers. Let's check and make sure they make sense. They have to be consecutive, so in order of each other. And we know they're even. 2, 4, 6. Nice. And I guess if you actually wanted to see if it works, you have to plug it back into this equation. So be careful with parentheses. The only time you can drop them, like over here in the green with the x plus 4, the reason you drop those is because there was nothing in front being multiplied and no power. But over on the left, there is something attached. So you can't just drop it. You have to actually distribute it to both pieces. So be really careful with that. That changes everything in the problem.